You recall that the generic formula for an exponential is y equals a times b to the x plus c. You'll remember that a growth pattern follows when b is bigger than 1. And a decay pattern comes from when b is in between 0 and 1. So here in this case, we see that we have 3 attached to the exponent, so therefore this is going to be a growth. The way to figure out the y-intercept is to take a and add it to c. In this case, we don't have something written in the c position, so we will just assume that it's 0, because you can add 0 to anything and have it stay the same. So the y-intercept in this case is 1/2 plus 0, or 1/2. The asymptote, if I could spell the word asymptote, that would help, right? Will be at y is equal to c. In this case, that means y is equal to 0. Notice 0 by itself would not be a correct answer. Make sure that you include the y equals portion of it. From here, we have all the information we need to graph. We start at 1/2, and it follows a growth pattern, but never touches the x-axis. And then it'll go up that way. Now let's go ahead and discuss some of the key features of this function. First, the domain. The domain is all present x values. In this case, if you thought about taking this function and smushing it onto the x-axis, everything would be covered, so the domain is all real numbers. Now let's talk about the range. Range is similar to the domain, but instead of smushing it to the x-axis, you smush it to the y-axis. So in this case, the only things represented would be between 0 and infinity. For example, we have nothing present for something like -2. There's no graph for that, so therefore it's out of the range. I'm going to use soft brackets because although 0 is the smallest number, the asymptote means it never quite touches there. Let's talk about the end behavior now. I like to think of end behavior in terms of a caveman first. As x gets big, as we go this way in the x direction, what happens to the y direction? Y also gets big. At this point, it's sometimes helpful to translate it into math words. So that's going to be x approaches infinity, then y approaches infinity. Because what's the biggest thing we know? Infinity. All right. Now let's look at the other direction. As x gets small, x approaches negative infinity, y approaches 0. It's never going to go past 0. It's going to get stuck there. One thing I want to point out really quick is you'll notice here in our two statements for end behavior, those are the same two ingredients that we have in our range. So you'll notice infinity and 0 are both present in the range and the end behavior. Just something to keep in mind if you ever get stuck on one of those. All right, now let's talk about the x-intercept. In this case, does it cross the x-axis? It doesn't. It gets stuck at the asymptote, so we can just say none. Now let's think about the y-intercept. It crosses at 0, 1/2. Note here, it would not be correct to just say 1/2. That would not be a correct answer. Make sure you write it in the form of a point. Next thing is this function increasing, decreasing, or constant. As we move from left to right, it appears to get bigger, so therefore it's increasing. If we move from left to right and it got smaller, it would be decreasing. And the last thing is, where is the asymptote? It's at y equals 0. We figured that out earlier. Make sure you have the y equals part of it, because a 0 by itself would not be a correct answer. As always, let me know if you have additional questions.